This is part 1 of a video about exponential and logarithmic equations and inequalities. This is AP Precalculus topic 2.13. If you appreciate this content, please give it a like. Find the inverse of the following functions. Be sure to use proper notation. Number 1, when you find the inverse of a function, you switch x and y and then you solve for y. F of x is basically the y. So when we switch x and y, the x will end up in the front, and we have 3 to the y minus 2 power plus 1. Now we just need to solve for y. Let's subtract 1 from both sides, so that gives x minus 1 is equal to 3 to the y minus 2 power. I'm leaving a little bit of space in the front because the way we get rid of a base 3 is to take the log base 3 of both sides. So I'm going to do log base 3 on the left and log base 3 on the right. On the left, I'm just going to bring that down. So we have the log base 3 of x minus 1 is equal to. On the right hand side, the log base 3 and the base 3 cancel each other out, and we are left with the y minus 2. So the last step is to add 2 to both sides. So we're going to get y equals the log base 3 of x minus 1 plus 2. However, using proper notation, instead of writing y, since we started off calling the function f of x, we should call the inverse function f inverse using this -1 superscript. Number 2, let's switch x and y and then solve for y. So the x will come out here in the front, and we have 4 times 2 to the 3y, and then minus 5. Now we need to solve for y. Let's start by adding 5 to both sides. So we get x plus 5 is equal to 4 times 2 to the 3y power. Next, let's divide both sides by 4. So that gives x plus 5 over 4 is equal to 2 to the 3y power. I'm going to move this over to the right a little bit because I can get rid of the base 2 by doing the log base 2 on both sides of this equation. So on the left side, I'm going to have the log base 2 of x plus 5 over 4. And on the right hand side, I'm going to have the log base 2 of 2 to the 3y. I just recopied the left hand side unchanged, but on the right hand side, the log base 2 and the base 2 cancel each other out, and we are left with 3y. Finally, we need to divide both sides by 3 to get y by itself. So we will have y equals. And you know what? Instead of putting a big old 3 underneath here, I think I will put a 1/3 in the front. So dividing both sides by 3, I'm going to write 1/3 and then the log base 2 of x plus 5 over 4. Once again, let's use proper notation. Instead of writing y, since the original function was g of x, we should call the inverse function g inverse using the -1 superscript. Number 3, we need to switch x and y and then solve for y. So in the front, we will have x equals, and then on the right hand side, 1/5 e to the 2y plus 3. Now we need to solve for y. Let's multiply both sides by 5. So we will have 5x is equal to e to the 2y plus 3 power. Let's move this over a bit. I can make the e go away by taking the natural log of both sides of the equation. I will copy down the left-hand side unchanged, so we still have the natural log of 5x. But on the right-hand side, the natural log and the base e cancel each other out, and we are left with 2y plus 3. Subtracting 3 from both sides gives us the natural log of 5x minus 3 is equal to 2y. Dividing both sides of the equation by 2 would give us an expression like this, the natural log of 5x minus 3 all over 2. Or if I want to write it with the 1/2 kind of in the front, I could do this. And we might as well go ahead and use proper notation now, and let's write h inverse instead of just y. But if I put the 1/2 in the front, I need to use an extra set of parentheses, well, brackets, and on the inside goes the entire numerator. Natural log of 5x minus 3. So either one of these is okay. If you want to use the previous version, then again, instead of putting y, you would just put h inverse. Number 4, let's switch x and y. So we will have x is equal to 3 times the log of y plus 1 minus 2. Now we solve for y. Start by adding 2 to both sides. So that's x plus 2 is equal to 3 times the log of y plus 1. To get this log expression by itself, we need to divide both sides by 3. So we will have x plus 2 over 3 is equal to the log of y plus 1. We can make this log go away, the log, by dropping a base e, well, not a base e, a base 10 on both sides of the equation. Log is understood to be log base 10. So a base 10 will cancel out a log base 10. So when I recopy the equation, on the left side I have 10 to the x plus 2 over 3 power, but on the right hand side I just have y plus 1. To get y by itself, we just subtract 1 from both sides. Let's go ahead and use proper notation though. So here's the final answer. K inverse is equal to 10 to the x plus 2 over 3 power minus 1. Number 5, let's switch x and y. So we have x is equal to negative 4 natural log of 2y. Now we need to solve for y. So let's divide both sides by negative 4. So that will give us x over negative 4 is equal to the natural log of 2y. We can make the natural log go away by dropping a base e on both sides of this equation. Base e, base e. I'm just going to recopy the left-hand side. So we have e to the and I think I'll just write this as negative x over 4 power. And on the right-hand side, the e and the ln cancel each other out. And we are just left with 2y. So the last step is to divide both sides by 2. So I think I will write it with a 1/2 in the front. Instead of writing y, let's put P inverse is equal to 1/2 e to the negative x over 4 power. Number 6, again we begin by switching x and y. So the x comes out in the front, and we have 2 minus the log base 3 of y over 4. Now we need to solve for y. Begin by subtracting 2 from both sides. So we get x minus 2 is equal to negative log base 3 of y over 4. We need to get rid of this negative sign, so think of it as dividing both sides by -1 or multiplying both sides by -1. Either way, we will get negative x plus 2. I went ahead and distributed the negative sign. And this will now equal the log base 3 of y over 4. To get rid of the log base 3, I can drop a base 3 on both sides of this equation, like this. So far, I've just copied down the left-hand side, but on the right-hand side, the base 3 and the log base 3 cancel each other out, leaving behind y over 4. To get the y by itself, I need to multiply both sides by 4. So it's time to write the final answer, so I'm going to switch from y to m inverse. So we will have m inverse of x, and we're multiplying by 4, so this is going to be 4 times 3 to the negative x plus 2 power. Number 7, let f of x equal 4 times 2 to the 5x minus 6 power plus 3, and let g of x equal f inverse. So g is the inverse of f. For what values of x does g equal -1? Since f and g are inverses, the input values and the output values will be reversed. In other words, f at a will equal b if and only if g at b is equal to a. That's just how inverse functions work. In this case, we are looking for where g at x is equal to 1. But because f and g are inverses, g at x will equal 1 if and only if f at 1 is equal to x. See how I switched the input value and the output value because they are inverses. We are looking for x, and we just found that x is equal to f at 1. In other words, we can find x by evaluating f at 1. That means plugging in 1 for x right here. So x will equal 4 times 2 to the 5 times 1 minus 6 power plus 3. So x will equal 4 times 2 to the, 5 minus 6 is -1, and then plus 3. 2 to the -1 power is 1/2. So we have x is equal to 4 times 1/2 plus 3. Half of 4 is 2, so this is 2 plus 3, so x is equal to 5. Number 8 is the same type of problem as number 7. H of x is equal to this expression, and k of x is the inverse of h. We need to find for what values of x does k of x equal 5. We need to find the value of x that makes k of x equal to 5. But since k and h are inverses, then k at x will equal 5 if and only if h at 5 is equal to x. This means we can find x by evaluating h at 5. So x will equal whatever we get if we plug in 5 for x right here. So x will equal 5 minus 2 times 3 to the 7 minus 5 power. So x will equal 5 minus 2 times 3 squared. 3 squared is 9. So x is equal to 5 minus 2 times 9. So x will equal 5 minus 18. So x equals negative 13. Number 9, p is equal to this expression, and m and p are inverses. For what values of x does m of x equal 3? Since m and p are inverses, m at x will equal 3 if and only if p at 3 is equal to x. We can find x by evaluating p at 3. So we will find x by plugging 3 in right here. So x will equal 3 times the natural log of 2 times 3 minus 1. So x will equal 3 times the natural log of 6 minus 1, which is 5. This is one version of the answer right here. I mean, without going into decimals, this is kind of what we have. We could use the power property of logarithms to move the 3 in the front to the exponent. In that case, we would have x is equal to the natural log of 5 to the third power, which is 125. So this is another version of the answer. For the next few problems, we are switching gears and solving inequalities. So for number 10, let f of x equal this expression. What are all values of x for which f of x is less than 0? My favorite way to solve an inequality is to make a sign chart. However, to make a sign chart, we first have to find where f of x is equal to 0 and where f of x is undefined. First, let's find where f of x is equal to 0. So let's set all of this equal to 0 and solve. The easiest way to solve this would be to put each log on opposite sides of the equation. So let's add the log base 3 of x plus 6 to both sides and essentially move this expression over to the right. Now we have this equation. Since we have a log equal to a log, the arguments must be equal to each other. The stuff on the inside must equal the stuff on the inside. So x squared plus x plus 2 must equal x plus 6. We can solve a quadratic equation like this by getting 0 on one side. So I'm going to bring down the x squared, but I need to subtract x from both sides. Well, these will just cancel each other out, so the x term is gone. Then we need to subtract 6 from both sides. That will give us a minus 4 over here on the left. So we have x squared minus 4 is equal to 0. This will factor as x plus 2 times x minus 2 is equal to 0. Using the zero product property, we find that x is equal to positive 2 and x is equal to negative 2. These two values will go on the sign chart later. In addition, now we need to find where f of x is undefined. You cannot take the log of 0, so f of x will definitely be undefined anywhere where this expression, x squared plus x plus 2, is equal to 0, or where x plus 6 is equal to 0. If this trinomial was factorable, I would solve by factoring, but it is not factorable, so I'm going to have to use the quadratic formula. Here is the quadratic formula. Make sure you have it memorized. So x will equal opposite of b, and b is 1, so x will equal negative 1 plus or minus the square root of b squared, so 1 squared is 1, minus 4ac, that's 4 times 1, which I don't need to write, times c, which is 2, all over 2a. So that's 2 times 1, which is 2. I can stop right here because I can tell that this equation will have no real solution. That's because under the radical, we have 1 minus 8. That's negative 7. If you take the square root of a negative number, that's imaginary, so we won't have any real solutions here. F of x will also be undefined when x plus 6 is equal to 0. So that means x equals negative 6 is another critical value. Now it's time to make the sign chart. Take these three critical values and write them in order from least to greatest across the top of the sign chart. We need to do a test value in each interval to find out if f of x is positive, negative, or undefined. In this first interval, let's use a test value of 7. F at 7 is going to be undefined because, look right here, if we plug negative 7 in, negative 7 plus 6 is negative 1. You cannot take the log of a negative number, so that's why f at negative 7 is undefined. In the next interval, let's use a test value of negative 3. So let's talk about f at negative 3. If I plug negative 3 in right here, I get the log base 3 of 9 minus 3 plus 2. Negative 3 squared is 9, and then you have the negative 3 and the plus 2. If I plug in negative 3 right here, we have minus the log base 3 of negative 3 plus 6. So simplifying this down a little bit, we have the log base 3 of 9 minus 3 is 6, plus 2 is 8. So that's log base 3 of 8, minus the log base 3 of 3. This is a positive number. So let's go ahead and put a plus right here. For the next interval, let's use a test value of 0. So let's talk about what f at 0 is. Plugging in 0 right here, we get the log base 3 of 2. That's the only number left. And plugging in 0 right here, we have minus the log base 3 of 6. The second log is bigger than the first log, so this is clearly less than 0. This is negative. So let's put a minus right here in this interval. In the last interval, let's use a test value of 3. So let's evaluate f at 3 and see what happens. So we get the log base 3 of 9 plus 3 plus 2. 9 plus 3 plus 2 minus the log base 3 of 3 plus 6. Simplifying this down a bit, we get the log base 3. 9 plus 3 is 12, plus 2 is 14. So log base 3 of 14 minus the log base 3 of 9. This is a positive number. So we will put a plus sign in this interval on the sign chart. We are looking for where f of x is less than 0. So the solutions will be in the interval where f of x is negative. Because we are looking for where f of x is less than 0, not less than or equal to 0, I'm putting open circles on these endpoints to remind me not to include these endpoints. So when we write the final solution, we will use parentheses and not brackets on the negative 2 and the positive 2. So we will say from negative 2 to positive 2. And that's the answer. Number 11 is another inequality. This time we need to find where g of x is greater than 0. Again, the steps for solving an inequality are find where g of x is equal to 0, find where g of x is undefined, and then use all of those critical values to make a sign chart. Finding where g of x is equal to 0 means setting this whole expression equal to 0 and solving. The first step is going to be to move this log expression to the other side of the equation by adding the log of 7x plus 16 to both sides. Now we have this equation, but if a log is equal to a log, then the argument will equal the argument. X squared plus 3x minus 5 will equal 7x plus 16. Let's get 0 on one side. I am bringing down the x squared, and I'm subtracting 7x from both sides. So that will leave negative 4x on the left. Subtracting 16 from both sides leaves negative 21 is equal to 0. Hopefully this will be factorable, so I don't have to use the quadratic formula. X squared will factor as x times x. 21 will factor as 3 times 7, or 1 times 21, but let's go with 3 times 7. Inner plus outer must equal the middle. Inner I have 3x, and outer I have 7x. To get a middle of negative 4x, I need a positive 3x and a negative 7x. That means I need a plus here and a minus here. Also notice that positive 3 times negative 7 does equal the negative 21 that we do need. The zero product property gives us x equals negative 3 and x equals 7. So these two critical values will go on the sign chart in a minute. Next, we need to talk about where g of x is undefined. It will definitely be undefined when the argument on the inside of either one of these log expressions is equal to 0. So let's set x squared plus 3x minus 5 equal to 0 and solve. 5 only factors as 1 times 5. That will not give me a middle of 3x. So we're going to have to use the quadratic formula again. X will equal the opposite of b, negative 3, plus or minus the square root of b squared, which is 9, minus 4 times a, which is 1, times c, which is negative 5, all over 2a. That's 2 times 1, which is 2. So x is equal to negative 3 plus or minus square root of negative 4 times negative 5 is positive 20. So this is really 9 plus 20. This is 29. Let's cheat and use our graphing calculator just to find these two solutions, decimal approximations. Let's use our graphing calculator as little as possible because you never know what part of the exam these questions will be on. So we will use the graphing calculator just for this one step. We had negative 3 plus or minus radical 29 over 2. So in the calculator we split that up as negative 3 plus radical 29 over 2 and negative 3 minus radical 29 over 2. So these are the two solutions, and I will round to the nearest 3 decimal places. That's 2 more critical values for the sign chart, but we are not finished with where g of x is undefined. G of x will also be undefined when 7x plus 16 is equal to 0. This will be a little bit easier to deal with because it's just a tiny amount of algebra. Subtracting 16 from both sides gives us 7x is equal to negative 16. Dividing both sides by 7, we get x is equal to negative 16 over 7. And what the heck, we've already been using the calculator and getting these decimals. Let's go ahead and get a decimal approximation for this one as well. I typed in negative 16 over 7, and it just gave me back negative 16 over 7. I really want a decimal approximation. Let's hit the math button and choose option 2 for decimal, and hit enter. So there you go, negative 2.286. Now it's time to make the sign chart. We have 5 critical values, 3 values where g of x is undefined, and 2 values where g of x is equal to 0. Put these 5 critical values across your sign chart in order from least to greatest. Since we've been using the graphing calculator for everything else, let's use the graphing calculator to help us decide whether g of x is positive, negative, or undefined in each interval. You can begin by typing g of x into the graphing calculator as y1. It doesn't all fit on the screen at once, but I have typed it all in as y1. I need you to adjust one setting on your calculator. Hit second window to adjust the table setup. And on your calculator, right here where it says independent, it probably has auto highlighted. I want you to switch over to ask and hit enter. Once you've done that, you can go to second graph to access the table. Because we have changed it to ask mode, we can type in any value that we want right here for x, and the calculator will evaluate y1, in other words, evaluate g of x at any value we pick. We need to pick a test value from each interval. In the first interval, let's use -5. Type in -5 and hit enter, and we get an error. Let's see why. G of x is undefined in this interval because, for example, when we plug in -5 right here, 7 times -5 is -35. -35 plus 16 is a negative number. And you can't take the log of a negative number. That's why g of x is undefined. So let's use another test value between -3 and -4.193. -4 will work. Actually, even before we go to the calculator, can you tell that g of x will be undefined at -4 as well? If we plug in -4 right here, that's -28. -28 plus 16 is a negative number. So g of x will be undefined. But just for fun, let's plug -4 into the calculator and see that error message. Okay, in the next interval, we need to pick a number between -2.286 and -3. These are pretty close together, but if we pick a number like, let's say -2.5, that's going to be between these two numbers. So let's do -2.5. Another error. Still undefined in this interval. Let's move on to the next interval. Between -2.286 and positive 1.193, well, you know what? 0 is in there somewhere. So let's go ahead and do 0. Still undefined. In the next interval, we can use a test value of 2 or 3. Let's do 3. Okay, this one is not undefined. This is a negative number. So we put that minus on the sign chart, and then for one more interval, we need a value that is bigger than 7. Let's just do 8. So plugging in 8, and this time we get a positive value. So let's put that plus sign on the sign chart. Because we are looking for where g of x is greater than 0, the solution will be in the interval where g of x is positive. I'm marking this endpoint with an open circle because we are only looking for where g of x is greater than 0, not equal to 0. So 7 is not to be included. So the solution set will be from 7 to infinity with a parenthesis on the 7 to show that 7 itself is not included. Or we could have written it as an inequality, and we could say that the solution set is x is greater than 7. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.